Okay. Hi, girls. Welcome to lesson 2 for evolution of the Earth's atmosphere. Your starter today is just to fill out this information about sodium. So pause the video. 3, 2, 1. Okay. Okay. So sodium has a symbol Na. The atomic number is the small one, so that's 11. Mass number is the big one, which is 12. Jokes, it is 23 approximately. On your periodic table, they round up. 23. The number of protons is the same as the atomic number, so 11. Number of electrons is the same as the number of protons, so that is also 11. Neutrons, we go mass, take away atomic, so 23 minus 11, which equals 12. It is a metal, which is in group 1. Period is another word for row. So it is in group row 3, so period 3. And it's in group 1, so it has 1 electron in its outer shell. Okay, now to draw, okay, we're going to come back to that as being silly. Okay, so lesson 2 is about greenhouse gases and climate change. And we've got a few little videos to go through. Okay, so the first is taken by some climatologists, and what they were trying to observe is ice caps melting. So they set up a camera and they watched a glacier, and what happens is what we call a calving event, and that's when a big chunk of a glacier goes into the ocean. So this is what it looks like at the start. So yeah, and we're just going to fast forward a bit. Okay, so just watch. So this is pretty scary. So this is ice falling into the ocean as the big chunk of glacier breaks off the main glacier. And that is just thousands upon thousands upon thousands upon thousands of liters of water going into the ocean. So you can see why sea levels are rising when that much water gets put into the ocean. So imagine watching this.
tell? Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. We watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. It's as if the entire lower tip of Manhattan
So that's
broke
New York
off,
City.
except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
Okay, so if you want to watch a good documentary on climate change, that Chasing Ice is really good and it is for free on YouTube. Okay, so unfortunately, it's only been very recently that our government and many other governments have taken climate change seriously. People are very excited there about the glacier, but they shouldn't be because it's horrific. So, yeah, some good examples of governments not taking it seriously was the Venice Council. Venice is really lays quite low and below sea level. And they decided that they would reject a climate change crisis plan. And moments after, a big wave came in and caused floods. So that was quite silly. Antarctica in February was about 18.3 degrees Celsius. I think the UK was about 8 degrees or something. So that's pretty scary. And it's a shame that a young Swedish teenager has more sense than most of our politicians when it comes to climate change. There's a nice little video of showing different countries' responses to climate change. Hold it, let me put this up. Nice little minute video. Okay, we're just going to play that. It's not essential. If you don't want to watch it, you can fast forward. So the moral of this story is that our governments just aren't doing enough. And the reason why is that there's such a big emphasis on the economy. All right. So, what are the greenhouse gases? We've got carbon dioxide, that's our major greenhouse gas, methane, nitrous oxide, fluorinated gases, and the other gases, the one that you probably need to know about in that sense is water vapor. So, when you write your notes, you can write water vapor in there. So, the greenhouse effect is really important, and without it, Earth, no life could live on Earth because it would be too cold. The enhanced greenhouse effect is that because we've got more greenhouse gases than what we should, we're seeing an increase in temperature. So let's just go through how the greenhouse effect works. So the first thing that happens is UV radiation from the sun. It is short wavelength radiation. The wavelength is small. It travels from the sun through the atmosphere and it hits the Earth's surface. Now it's absorbed by materials on the Earth's surface and it's re-emitted back into the atmosphere as long-wave radiation. And the long-wave radiation is called infrared or IR radiation, and that's the radiation of heat. So if you just don't touch your face, you shouldn't do that during a pandemic anyway, but if you hold your hands just maybe a centimeter from your skin, you should feel heat radiating off your body. That is IR radiation. So once the infrared radiation has been emitted back into the atmosphere, greenhouse gases will absorb it, re-emit it back to the Earth's surface. So instead of leaving through space, it warms the Earth's surface, and that's why we get an increase in temperature. So what I might recommend that you do is copy down this diagram or find another diagram and just annotate the steps. So what have humans done to cause the enhanced greenhouse effect? We've got another nice little video here.
It all started with a big bang. Wait, we don't have to go back that far. The Earth was formed 4.5 billion years ago. It's still too far. Try this. It's the Middle Ages. People in Britain run out of firewood, start burning coal, but they use up the coal on the ground. Miners dig deep. Coal mines fill with water. Samuel Newcomen invents a coal-burning steam engine to pump out water so miners can keep digging. James Watt makes it practical for other uses. Now we have ingredients for the Industrial Revolution, fossil fuels, and a way to put them to work. All hell breaks loose. Coal miners bog down lugging coal. Rails make it easier. Rails and steam engine combined make a railroad. Michael Faraday makes the first electric motor. Nikola Tesla invents alternating current. Soon utility companies start burning coal to generate electricity. Meanwhile, Edwin Drake drills the first rock oil well in Pennsylvania, and Carl Daimler builds an automobile running on petroleum. Coal tar and oil are turned into industrial chemicals and pharmaceuticals that prolong life, more population growth. The Wright brothers start oil-fueled aviation. Fritz Haber and Carl Bosch make fertilizer from fossil fuels. Fertilizer and oil-powered tractors expand food production, feeding more people. World War I is the first fossil-fueled conflict. Then comes World War II, giving us guided missiles and atom bombs. In between is a Great Depression, partly caused by overproduction. Powered assembly lines make products faster than people need them. Advertising executives invent consumerism to soak up overproduction. It's the 1950s. Advertisers used television to hook new generations of consumers. In the 70s, there was an oil shock. Everyone's shocked to realize how dependent they are on oil. With the energy crisis, the environmental movement is born. But oil prices fall and everyone forgets energy shortages. There's a showdown between market and planned economies. Market wins. Goodbye, evil Soviet empire. Politicians decide the market will solve everything. Personal computers arrive. Globalization takes over when the market notices labor is cheaper in China. Suddenly everyone has a cell phone, but world oil production stalls out. China is now burning half the world's coal to make export products. But where will China get more coal and oil to fuel more growth? Environmental problems everywhere. Rising CO2 levels lead to record heat waves, floods, droughts, oceans acidify, topsoil erodes by 25 billion tons a year from industrial agriculture, ancient forests disappear, species go extinct at 1,000 times normal rates, fresh water is scarce or polluted. Oil companies drill in miles of seawater because the easy oil is gone, but a deep water oil platform explodes and fouls the Gulf of Mexico. Manufacturing moves to polluting countries where labor is cheap, while the US becomes a casino. The financial sector is 40% of the economy. But Wall Street is over-leveraged. Banks fail, unemployment soars, credit evaporates, the economy is on the verge of collapse. Okay, present time. It's amazing how far we've come in 200 years, just 3 human lifetimes, from the beginning of industrialism till now. But where are we headed? We can't keep doubling human population. We can't keep dumping carbon in the atmosphere. We can't keep ruining topsoil. We can't keep growing population and consumption or basing our economy on depleting fossil fuels. We can't just print more money to solve the debt crisis. It's been an exhilarating ride, but there are limits. Now, it's not the end of the world, but we have to do 4 things fast. Learn to live without fossil fuels, adapt to the end of economic growth as we've known it, support 7 billion humans and stabilize population at a sustainable level, and deal with our legacy of environmental destruction. In short, we have to live within nature's budget of renewable resources at rates of natural replenishment. Can we do it? We have no choice. Alternative energy sources are important, but none can fully replace fossil fuels in the time we have. Also, we've designed and built our infrastructure for transport, electricity, and farming to suit oil, coal, and gas. Changing to different energy sources will require us to redesign cities, manufacturing processes, healthcare, and more. We'll also have to rethink some of our cultural values. None of our global problems can be tackled in isolation, and many cannot be fully solved. We have to prepare for business as unusual. Our best goal is resilience, the ability to absorb shocks and keep going. If we do nothing, we still get to a post-carbon future, but it will be bleak. However, if we plan the transition, we can have a world that supports robust communities of healthy, creative people and ecosystems with millions of other species. One way or the other, we're in for the ride of a lifetime. Understand the issues and pitch in. It's all hands on deck.
Okay. So, one of the things that you need to be able to mention from that sort of list, things that have caused global warming is combustion of fossil fuels, so in engines, planes, cars, factories, and that releases locked up carbon dioxide into the atmosphere. Deforestation increases carbon dioxide concentrations because less trees means less photosynthesis. And as we know, photosynthesis takes in carbon dioxide. Peat. Now, you wouldn't have learned about peat yet. It's actually in the biology spec, not the chemistry, but may as well go over it now. So peat is a brown deposit made of partially decomposed plant matter, and you find it in the wet, acidic conditions of bogs. It's a very useful product because it can be used as compost for gardens and farms. Problem with it, though, is when the microorganisms break down the peat, carbon dioxide is released from respiration. It's also quite useful as a fuel, so when it is burnt, it releases carbon dioxide as well. So it does contribute to global warming and climate change. So destruction of peat bogs releases carbon dioxide. Livestock farming, digestive processes, i.e. farts, releases methane into the atmosphere. Landfill, because we get more people, we have more and more waste. When that waste is broken down, methane and carbon dioxide are released as products. So there's lots of ways there that humans cause global warming. So what are the consequences of global warming? Ice caps melting and seawater expands, so sea level rises and we get flooding. Increased evaporation means we get more severe and frequent storms and drought. loss of habitat, food and biodiversity for organisms, changes to migration patterns, changes of distribution of organisms. So an example might be distribution means where organisms are found. So if it's warmer, mosquitoes will survive in wider areas, so you get more risk of diseases such as malaria. So at the start of this year, we had really, really severe floods in the UK, and these have been becoming more and more frequent in Australia, which some of you don't know me, but I am Australian. I don't know if you can pick from my accent. But Australia has always had bushfires, but the fires that we had at the start of this year were absolutely horrific. So I'll just give you some context. So this is a map of England, and this would be the area of Australia that was on fire. So all of London, up to Cambridge, up to Norwich, down past Brighton. So it's a massive area. And if you want to see a video of how severe a bushfire is, just have a look at this. So the firefighters won't hurt here because they have specialised equipment, but scary, scary, scary stuff.
Watch 38 coming down.
They're putting a fire blanket there to protect them. Oh, look at that. Yeah, so very, very scary stuff. And we're already beginning to see climate refugees. People have had to move because of their homelands being flooded or cyclones and stuff. And one of the major places where this is happening is Bangladesh. So we've got one more little video here. Okay. And the unfortunate thing for Bangladesh is that they release less than 1% of the world's carbon, but they're one of the countries who is having the most effects.
12 million of them live in and around river systems where there's a high risk of life-threatening floods. Another 4.5 million children live in coastal areas regularly struck by powerful cyclones. Almost 500,000 are Rohingya refugees living in flimsy tents that barely protect them. And a further 3 million children live inland. That's where farming communities suffer increasing periods of drought. Sarah Khairat has more.
Each family has a story to tell of loss and devastation, and all because of climate change. Muhammad left Bola Island in the Bay of Bengal, where rising water levels and floods are fast becoming the norm.
We came to Dhaka because the river washed away our home. There's no work there, so I'm here to try and find one. I have a lot of loans to repay.
He's finding it hard to adjust to his new city life, but along with his wife, worries most about the future of their daughter.
My hope is to raise my daughter as a good human being. I would like her to live in a decent environment.
UNICEF reports that climate change is displacing millions of Bangladeshis, and many children are missing out on an education, with some forced into child labour and even prostitution. It says girls are the most vulnerable.
It takes a lot of money to send your children to school in Dhaka. I can't afford to educate my children. My son does not go to school.
2/3 of Bangladesh lies 5 meters above sea level, and the Bay of Bengal has one of the fastest rising sea levels in the world. Experts are warning that if nothing is done to reverse these changes, the consequences for the country's 160 million people will be dire.
The global leaders have to commit that they have
to do something serious in respect of emissions. They have to develop, they have to enhance their emission that by the year 2050 or 2100, we have to go for a zero carbon emission, so that this is not only the Bangladesh will be safe, whole world have to be safe.
The World Bank says by 2050, more than 30 million people in what it calls this highly climate vulnerable country will be displaced. That may be decades away, but for those living in Dhaka's overcrowded slums, it's a reality right now. Sarah Khairat, Al Jazeera.
Okay, so very, very sad. And really, it's not fair as well. So, yeah, it's not good. So, how do we know that global warming is actually happening? So, there's lots of climate change deniers out there, especially our American president, Trumpy. So, global warming is now 100% accepted by the scientific community. Well, maybe not 100%, but almost all of the scientific community think that there is a link between greenhouse gases, global warming, and climate change. And there have been thousands of peer-reviewed studies, and we've got lots and lots of evidence. However, you must not always just accept what you read, and that's because there is some people have bias, especially those people who are invested in fossil fuels. It's very, very complex process. It's hard to put it into like a simplified model. And any study that doesn't have peer review is a real problem, because peer review stops people from preventing false claims, and it reduces bias. So if you're answering an exam question on this, you need to, and you're asked to do some critiquing of any evidence, think about whether there's bias, whether it's oversimplified, or whether there is a lack of peer review. So what evidence have we seen to link climate change, to link temperature to carbon dioxide? So these are some nice little graphics here. So what evidence is there that the world is getting hotter? So where average temperature there is quite low, below average, and then you'll see that in the last sort of 50 years, we are starting to get hotter and hotter and hotter and hotter and hotter. So this goes up to 2015. So every year, basically, it's getting hotter and hotter, and we have evidence of this. Scientists have linked this to an increase in carbon dioxide levels. Of course, correlation does not prove causation, but it is really highly correlated that as our CO2 has gone up, our temperature has also increased. We've also seen a dramatic decrease in our ice amounts. So 1980, look at the area it covers: 1990, 95, 2000, 2005, 2010, 2015. So in the Arctic Circle, the ice has actually receded quite a lot, which is scary. Okay. So that's the evidence that we have. And it's a really common exam question, or questions that you will need to interpret graphs like that and make conclusions and also critique them. So if we go back to our PowerPoint, this would be a really typical question. This would be a 6-mark question. So it says, evaluate evidence for and against the theory that an increase in the concentration of carbon dioxide in the atmosphere causes an increase in air temperature. So there are some really important points here. So evaluate is our first one. Now, evaluate for, against, excuse the bad writing bit, against, and conclusion. Okay. Use data, numbers. And your own knowledge, and so you have to think about what include things that you know about global warming. So we need to talk about why an increase in concentration causes an increase in temperature. So, okay, let's try and do this without losing our mouse. Okay, so evidence 4 is that as your carbon dioxide has increased, we have had an increase in air temperature. So we've got a positive correlation as carbon dioxide levels increase, temperature increases. Now, from our own knowledge, we also know that carbon dioxide absorbs and emits long wave IR radiation. So essentially it traps heat. So there's definitely a mechanism there. We know carbon dioxide can absorb and emit long wave radiation. And as we can see, as carbon dioxide increases, so has temperature. Against. So carbon dioxide increases quite steadily, but there's big fluctuations with temperature. So fluctuations in temperature. Some years it's actually decreasing. Some years it's decreasing. And they're only looking at one factor. They're only looking at carbon dioxide. There might also be other factors that have contributed to temperature rises instead of just carbon dioxide. And we're only looking at one graph there, so it's not 100% conclusive. Okay. Okay, so this is another question here. You don't have to do B, so ignore B. So this question is about climate change. Calculate the mean yearly increase in sea level between 1992 and 2016. So just take a minute, see if you can work out the answer to that question. Just remember, mean yearly, so average per year. So just pause the video if you need more time. But from 1992, the change in sea level went from 0 to, what's that, 74? So the change is 74 millimeters overall. but that happened between 1992 and 2016. So that is 16 plus 8. That is 24 years. So the mean is 74 divided by 24. Calculator. So 3. 3.0 sorry about the handwriting there. Okay, so we're going to ignore B. And these data was collected by a single scientific group. Give 2 reasons why more evidence is needed to support any conclusions made by this scientific group. So there could be bias, lack of peer review, that's because we've only got one person doing it, and our models might be simplified. So those were those 3 points from before. Ignore that. Carbon dioxide is also a greenhouse gas. The figure below shows how the concentration of carbon dioxide has changed. So we need to talk about how it's changed. So if we look at our shape of the graph, it was constant or the same until about 1925. So that's going to be our first conclusion. It then increased at a slow rate till about 1975. And then it increased at a fast rate from about 1975 until now. Okay, so these are conclusions that you can make. Okay, so look, that's 1965. I didn't do very careful working at the time, but anyways, you can see the general gist. So your task for today, the first thing is just to do a summary of what you've learned about global warming and climate change. This is the sources where what humans do to create these sources, the evidence for global warming and limitations. How does the greenhouse effect work? That's sort of the IR radiation and the UV, and what are the consequences of global warming? So that would be a nice summary. You can put it on a poster, do it on a Word document, and that could be for your revision. You are then going to complete 2 Seneca tasks. One is on global warming and the other is on the atmosphere stuff from last week. So I hope you're all well and look forward to seeing your answers. Please can you take a picture or upload this onto Frog, or for my classes, Google Classroom, or if you can't do that for some reason, just send it to your teacher. Thank you. See you later.